Hello everyone. In this video, we'll continue exploring the working of observability using a multi-step conversation as an example. Now, before moving on, let's discuss some theory behind it. Basically, if you take an LLM and put in a query, it's going to give you an output, right? Now, next, when you follow it up with a question, um, and it will still give you an output, but this time it will not have any context of what the previous conversation was. This is because LLM by default is stateless. What I mean by that is at the end of every execution, the LLM is simply going to forget whatever the input or output um, that was there in the workflow, right? That's how LLM works by default. Now, to fix this issue, what we can do is incorporate some memory into it, right? This is done with the help of a concept called persistence. What this basically does is to save the states at each and every node in the workflow and then use it further in the conversation. So by doing so, you're persisting the memory and using it in your future workflows, right? So this is done with the help of checkpointers. So what we can do is at every stage, you create a checkpoint, and this basically saves the state of the workflow at that particular point, right? Now, with taking this as an example, when a user inputs a question or a query here, within the database, the human's question is added, right? And after the LLM, when the AI outputs an answer, that gets appended to the database as well, right? So this gets saved in the database. Now, when the user follows up with a new question, but that's related to the previous query, a checkpoint is created here. So the same the human's query gets appended to the database. But this time, when the information goes to the LLM, it not only has the human's latest query, but also has information about what the conversation and the output was from the previous execution. So now, when it answers the latest human's query, it will also take into consideration the previous uh, uh, details, right? That way it will give you an appropriate answer, and this basically forms the multi-step conversation. And this is quite similar to what you might see in apps like ChatGPT, where you can keep on going one after the other, throw questions at it, and have a lengthy conversation, right? Now, one more thing that you'll see in ChatGPT is the ability to create new chats. So you can create a new chat, throw in a bunch of questions there, come back to the old chat, continue the conversation from where you left. And this is basically implemented with the concept called threads, right? So in simple terms, it's like a tag. You attach a tag to the conversation, and that way the database will know that these particular chats belong to a certain conversation and the other bunch of chats belong to a different thread. So this is how you go from a stateless LLM to an LLM with memory. And these databases can be anything. For this demo, I've used a SQLite database. Now let's go back to LangSmith and try to implement it using a simple workflow. So I have this code, and this is in LangGraph. And of course, we're not going to need to understand how this is done. What we'll do is we'll try and throw in a question, and here no memory is attached. It's a simple workflow. It takes in an input and gives an output. Let's see how it goes, right? And this is similar to the first video, where the LLM is basically going to query query the user's question. Let's say, hey, how are you? Probably not going to answer this. Let's just go with hey, right? And let's run this. Yeah, so it has run this. It's a block of text. You can go back to LangSmith to try and get a proper answer. This is the latest trace, and here you can see um, the human input was hey, and the AI as output hello, how can I assist you today? Right, now let's go back, follow it up with another question. What's the capital of India? Let's run it again. Let's go back here, and this should have created a third trace, basically second for this demo, but yeah. Right. So here we have the input. What's the capital of India? The capital of India is New Delhi. Perfect. Now let's follow it up with another question. Uh, what's the best dish in this city? And let's run it again. Going back to LangSmith, we have the latest trace. And now you'll notice that the AI message says, I'm sorry, but I don't have information on your specific location and so on. This is because we don't have the memory aspect implemented it, right? So while it was answering the first two times, when you start asking questions that related to a previous question, it just doesn't know it, right? Because also you can see here that the input is just your latest question. It does not have context of the previous inputs. So what I'll do is go back to the code and implement the checkpointer. So what I'm doing is I'm implementing a connection within the SQLite 3, and then implementing it within lang graph, and here I'll throw in the checkpointer. So what's happening is every time the app gets compiled, it says, hey, go check back within the database if there are any checkpoints, and take it into consideration for a further context, right? And finally I'll create a config. This is where you pass in a thread ID. This is to say that all of the conversation are within this particular thread, and within my result I'll pass on this config file, config details as well. Now let's go back and ask the same bunch of questions. Hey, uh, what's the capital of India? And let's run it now. You can go back here. Not sure why it doesn't turn up without refreshing, but yeah, this is the latest trace. If you go here, we'll see what's the capital of India. The capital of India is New Delhi. Perfect, right? Now let's follow it up with a question that's related to the earlier query. Uh, what's the best dish in this city? Right. Now if you see, the block of text is seems a lot bigger, right? This is because it has also passed on the details from the previous chat. Let's go and see it within line graph now. So this should be the latest one, right? So if you see here, um, what's the best dish in the city? The output, let's say right here. Right. So you have the input here. What's the capital of India? The capital of India is New Delhi. What's the best dish in the city? So when you're for this particular run, all of this went in as the input. So when the AI is generating the answer, it has context that we are speaking about New Delhi from the previous chat, and it takes in the latest question and then answers according to it, right? Butter chicken, paratas, kebabs, and so on. So this is in so this is how the concept of thread and a multi-step conversation works. Now within LangSmith, there's an interesting thing here. You can go to something called as threads within here. There's a separate section for it. And if you go here, you'll see the thread ID is created. We called it thread 001. So that has been created here. And within this, it forms like a chatbot style conversation. So it says, hey, capital of India, it's New Delhi, and this is human and AI again. Now let's follow it up with another question. Um, Give me the recipe, uh, not chocolate chip, for the first one, right? So by first one, I mean, um, what was it? Butter chicken here, right? So, what did it run so quickly? Okay, let's come back here. Right, now it has three traces. You can go back here and see. Oh, right, it's taking some time. But yeah, there you go. Yeah, give me the recipe of the first one. Certainly, here's the recipe of butter chicken. And this time it had context of all the four messages, and especially the previous one where it knew that the first dish that we're talking about is butter chicken, and this is how it um, has the related context. If you go back to the project, you will notice that the previous chats or the previous traces does not have the does not get included within this thread. So this thread is only included when we pass it on here. Now what we'll do is we'll create a new thread, right? Let's call it 002 and pass in the same query. Give me the recipe of the first one. Now this in essence, or this should be treated as a new chat, right? Um, Although we have the memory implemented, within this memory, a different thread has been created. So this is going to act like a fresh chat, right? So as you can see, it says certainly, but I need a little more confirmation about information about what recipe you're referring to, because this time the input does not like cross-reference the other threads here. Now we can follow it up with questions here. I meant butter chicken, and let's pass it on. Did it get created? Yes. Okay. Yeah. So it's loading here. So you have the human message, the AI one. I meant butter chicken. I think it's having some latency in displaying, but yeah, there you go. So you have the details over here. So this is how a multi-turn chatbot can be traced within LangSmith. You can create separate thread IDs to segregate the chats. Now, if we go back to thread ID 1 and ask it to what about the dish 2, how long does it take to prepare it? And if you run this, I've changed the thread. So this time it will have context of what dish to I'm referring to. All right. Um, this has been delaying a bit today, but yeah. So there you go. You have the recent thread that got updated, and if I go into this, it's probably gonna take some time. But yeah, the dish two was chole bhature. So It's a bit annoying today. Um, yeah. So here you have the recipe of dish 2 and the preparation time as well. So this is how you can incorporate memory, threading, and tracing for a multi-step conversation. This is a secret database we created, and you can see how the thread has been created. We started with thread 1, went to thread 2, came back to thread 1, and yeah, that's pretty much for the demo today. Um, do let me know how are you liking this sort of series. In the next video, I'll show a demo of the tracing within for a RAG based pipeline. That's going to be a little more interesting and complex. So I'll see you then. Thank you for watching it so far. Bye.